Hello team, today's challenge is capitalized Fibonacci, where we're given a string and we need to be able to capitalize certain words based on whether whether the index of the character matches or falls on the Fibonacci sequence. Just a standard Fibonacci sequence. Like we could obviously shift it and play around with that, but the standard one is this, where it starts with 0, 1, 1, 2, 3, 5, 8, 13, all the way up, right? And it can get huge in a hurry. But we're going to use that to figure out which letters to capitalize and which letters to lowercase, right? There are really two ways to do this that I found. Maybe you found others. Maybe you let me know in the comments. But I found two ways. So the first way is to go in here and we set a const of Fibonacci like this. Set it equal to get Fibonacci, if I could spell it. Wow, that my fingers do not want to work on this word. That is disrespectful to Fibonacci, honestly. But here we are, string.length. Excellent. What we're going to do is we're going to generate that array, right? That's one way to do it. So we could go in here, grab this, let's go up, create a function just like this. It's not length, it's just a number, right? And inside of here, we are going to generate that Fibonacci array, right? So that we can test against it. So to do this, I'm going to set up an array, and I'm going to set the first two elements, okay? You might do it a different way, and that's okay, right? For this challenge, we can safely do this because of how we are executing down here, right? Might need a little bit of refinement if we're actually doing real work with the Fibonacci sequence. But for today, this works, and we're going to do it. So right here is a while loop, okay? And while that Fibonacci sequence at -1 is less than the number, right? So we're getting the last value and comparing it to whatever our number is, okay? While that's the case, we are going to push, okay? So we get that fib, we push into it just like this. And what do we push? Well, it's this plus the one right behind it. So the index at -1 plus index at -2, okay? And then we return that, so right here, and that brings us back into here, right? So now we have an array of numbers following the Fibonacci sequence, starting with 0, because that's how we set this up, okay? Down here, we get rid of that, and we go to lowercase, which allows us to normalize the data, right? We lowercase everything and uppercase just what we need. Conversely, you could uppercase everything and lowercase just what you need, right? You could do it either way if that's what you like. But right here we have replace, and we're going to replace all the letters from A to Z, right? Just by single letter, okay? So no pluses, no stars, no nothing like that, but we do want it to be global. So we're going to find every single letter and check, okay? And we're going to send it into a function. That function is going to be the match, whatever the letter is, and the offset, which I honestly, I just like to put as index because they line up that way, okay? So index is what we'll use today, but if you want to stay with offset, you absolutely can, right? Now in here, we're going to check some things, okay? The thing that we're going to check is we're going to see if Fibonacci includes index, okay? So if we're at an index that is in our sequence, then we do something. What do? Well, we take that match, if I could spell it, to uppercase, just like this. Excellent. Otherwise, we just return match, okay? And that does it, okay? So with this one, we have generated an entire array. And it goes quite quick because we're only generating enough of our sequence to cover off the indexes in our string. That's very important, right? If our string is something like 200 characters, right? Then we will get, I forget what the number is. It is whatever the one after 144 is, right? 144 being meaningless. I'm saying useless words, but trust me, it's in there. Okay, 144, and then whatever the next value is, that's what our string would be, or what our Fibonacci sequence would total out to, and that would be maybe 11 values, I think, right? I don't really remember, but there it is. Okay, and then we get that whole sequence, which goes really fast, and we compare it against our string to figure out what's what. So we see if our index is included, we do the thing. Okay, we can also do this with math, and that's my preferred way to do it. So if I'm just going to grab the main function, comment everything out, creating a little bit of space just so that we know which is which here. Okay, and I'm going to paste that back in. Now for this one, using the math version, we can actually check to see if a specific index is in the Fibonacci sequence. Okay, and that sounds really, really weird, but stay with me for a second. So this change here, we're going to do it right at the return for this replace. Okay, and what we do is I'm going to create a new function. It's going to be called is Fibonacci number, just like this, sending in index, kind of like we did before, but this time math-based. Okay, function is Fibonacci. We're going to change this back to number, and inside of here we're going to check two things, right? And if either one of those is true, then we have a Fibonacci number. Okay, the first is a positive form, so I'm going to call it POS for positive, and it is going to be 5 times number squared plus 4. Okay, the plus is where the positive comes in. We're about to change this to minus. I'll show you in a second, but we have this number 5 times number squared plus 4. Okay, and we take all that and we wrap it up inside of math dot square root, just like this. Brilliant. Making a copy, changing the second one to neg, I guess, right? For positive, negative. Probably could use better terms in there, but the plus sign to a minus sign. So again, if either one of these, if the square root of 5 times number times 2, or to the number squared, sorry, 5 times number squared plus 4, or the square root of 5 times number squared minus 4 is an integer, then we have a Fibonacci number. Okay, this bit of math is based off of something called Binet's formula, right? Binet was an 18th century mathematician, right? French mathematician. So he studied Fibonacci and he figured out that there was some math to it. It's based off of the golden ratio, right? So 1.618, right? And he kind of did that. And then people manipulated that to get us this formula, okay? So down here we can return. And what do we return? Well, we return number.is integer, which returns true or false, the positive form, or grabbing all this again, copying it down, tabbing in, making it pretty, the negative, just like this, getting rid of these, okay? So if either one of these are an integer, then we have a Fibonacci number, okay? Which means that now this should work, which is brilliant, right? Using that math from Binet, right? Or a future version of it, right? Binet's formula calculates the number at a specific index, I guess, whereas we're getting the index of a number and relating it to see if it actually is a Fibonacci number. So a little bit of difference, but the math still works, okay? And there it is, right? We have two different versions of this. The first one, we created that entire array. Thankfully, even on very long strings, like 400 or 500 numbers, we're only ever going to have an array of maybe 15, right? Depending on what it is, because the numbers get exponentially bigger. They get huge in a hurry, right? Which means that if you're looking at these strings, this big one here, there is a huge difference between some of these letters. So where is it here? We have I think the last one is the A, right? There is nothing after that. But if you roll back, the next one is this M. So there's what looks to be about like 30 characters in there. I didn't count. I'm totally guessing. You can count if you want. But the distance gets smaller as you go backwards. So the M goes back to am I missing it? There's a T, and then it gets closer with the O, and then closer still with the S, and then they're all jumbled up right at the beginning, right? So the further out, the longer the text, the more space that is going to be between each individual capital letter, right? Which means that our index is always going to be pretty small, even if it's thousands, right? It changes in a hurry. But I'm assuming even with 1,000 characters, we're going to be pretty safe here, okay? So we did that. And then we used Binet's formula, or an offshoot of that, right? A derivative of that, to calculate if our index is a Fibonacci number. And then we slid that in. Performance-wise, they are almost the same. This one is a little bit faster, but not much, right? In my testing, I think it was maybe 20,000 ops per second faster, so not a lot. I think one was 160,000 ops versus, you know what? I have it right here. Why am I quoting it? There's Binet. So yeah, one was, if we create the sequence, it was 112. And if we do that, it's called the perfect cube formula, right? Then it's 142. So really 30,000, right? 30,000 ops per second. Maybe that's a huge difference for you. Maybe not, but it feels pretty close to me, right? Doesn't feel like either is a super clear winner, because if I took this into another browser, it might be flipped, right? I haven't tested other browsers, but it could easily flip depending on how they've optimized their JavaScript runtime, okay? But yeah, so jumping back, there was even an example here, like this formula even works for, this one is on the Fibonacci sequence, right? I couldn't even tell you what this is. Millions of millions, it works, okay? Which is great. So here we are. This is our code for capitalized Fibonacci, right? Did you like it? Which one did you like? I guess is the real question. Do you prefer creating the array? Again, it's going to be quite small, right? It's rare that you get over 20 elements, right? I'm guessing. Or did you prefer to do it math-wise, right? Does this math make sense? I mean, it does take a little bit. I don't fully understand the math. I'll tell you that. So I was about to say it does take a little bit to understand, but you don't really need to understand the math. You just need to be able to use it. And that's what we're doing here, which allows us to figure it out and execute on that, right? So which one did you like? Or did you come up with another one? Hit me up in those comments. Let me know. Otherwise, again, this has been Capitalized Fibonacci, and I will see you tomorrow.